in an earthquake, we actually have what's called liquefiable soils here, which means that if you get an earthquake, the soil underneath you will literally turn to a mush. It's like quicksand. And so, depending on how bad it is and what your building is. So this jello is actually a good representation of that. And what's down below the jello at the bottom would be considered like the hard soil that you have, the hard pan, which is called marl, which is about 50 feet down. So you have to go 50 feet down before you can start getting into good sand here. So it's actually one of the hardest places to design. Usually we have to put piles that go down 100, 120 feet downtown if you want to put a building on something. So you got to go that far down in order to actually get anything out of your soil. So the stability of this is awesome. It's really staying nicely together. But you can see also how it's moving all over the place. And that's actually something that's in earthquakes that actually will happen. Again, we were talking about those soft soils. That's actually going to happen. All right, now let's see what happens.
Oh, just I thought it was like a big.
This is where we're starting. I mean, we want to take this as far as we can. All right, and now let's see what happens. Let's see if there's a difference. Let's see if the napkin is cheating. If the napkin is what's holding it together, we got bigger problems. But
you can see the jello trying to bulge out through the napkin. Because if it wasn't for the napkin, it already soaked.
They've got a good slab. All right. Okay. All right. So now let's see if there's a difference between the way this reacted the first time. So in the light one, it's tipping a lot more than it did before, didn't it?
Yeah, it's sinking.
Okay, and now let's see what happens in the big earthquake.
It's
still sinking.
It's sinking way in.
But the napkin holding it up, so it ain't going for it.
All right.
Foundation.
Yeah, but that's the thing is you guys have a really good slab on grade. You guys have a good. This would be called like a spread footing. Like this is really going to spread the load out. So let's see what happens. And it's also a light building, so in this part it should do really well. Okay. Let's see what happens.
Oh, we about to die.
It's holding up all right. All right.
Just don't put that book on.
Wait.
You want me to start with the heavy one or the light one?
Put the heavy one on.
Hey,
The
stop
heavy
with this one right here.
All right. It worked.
Damn, bro. Oh, no.
Oh no, y'all might survive. Yep.
I'm on the Texas Nationals again.
All right. So in the light shaking, it's there's a lot of rocking and rolling there. And now in the heavy shaking.
Come nuts, we design boats.
It's digging in.
It's digging in.
Yeah. Let's make sure it survives for the big book.
It's gonna sink. There we go.
Is it going to sink? They've got a good foundation under there.
It's gonna sink.
No, see, they've got a good foundation under there.
Because they got it.
Because it's all solid.
But that corner right
It's
there,
kinda on
on
this
her
side,
side,
it's
it's
kinda
all
leaning.
digging in.
It's leaning because of the book not stable.
There we go.
Book
All
on
right.
the wrong way.
I tell you, we design boats. See how I think rocking?
I think the building's
Oh! Lost to me. I wouldn't eat that.